Then let's talk about more detail of exponential function. So as we discussed before, y equal to b to the x. That is the general equation of the exponential function. So let's make some example. Let's say y equal to 2 to the x power. Then we can find some x point here. Maybe negative 2, negative 1, 0, 1, 2. Then this all will become 1/4, 1 over 2, 1, 2, 4 like that. So if you draw the graph of this function, then this is going to be somehow like this here, right? Okay, then now, so in this case, we keep on increasing maybe 3 and 4 and maybe 10 or maybe 100, something like that. We know that this graph keep on moving up and up here, right? But now, what about the other side? What if we choose maybe x equal to negative 10, negative 100, negative 1000, something like that? So my question is, do you think 2 to the negative 10 is still bigger than 0, or 2 to the negative 10 will be now less than 0? Similarly, 2 to the negative 100, is it going to be bigger than 0, or 2 to the negative 100 is less than 0? Both cases, the answer is bigger than 0 here. The reason is, now we know this property, a to the negative n equal to 1 over a to the n. Therefore, 2 to the negative 10 power, if using the calculator, then this becomes 0.00098. If you do 2 to the negative 100, then this becomes 7.9 times 10 to the negative 31, which means maybe 0.1, 2, 3, 4, 5, 6 until 30 and then 7, 9, something like that. Okay? Anyway, all this value still bigger than 0 because it is not exactly 0. However, we can say those values are close to 0 though. But it's never going to be 0, and then always under y equal to 0 position here. Okay? Therefore, now on this side line, it keeps on going closer and closer, but it never passing y equal to 0 line or x-axis, right? Since this curve never crossed x-axis, this x-axis line this is our horizontal asymptote. Okay? So, exponential function graph, we have horizontal asymptote here. So, when summarizing, y equal to b to the x, it never across y equal to 0 over x-axis line. So, y equal to 0, that is our horizontal asymptote. Okay? Okay, now another one. Let's look at GeoGebra and then explore some graph. So I'm gonna create the fx equal to 2 to the x power, and then so I'm gonna make a little bit lower so that we can see a little better, and then gx equal to 3 to the x power, and then hx equal to 4 to the x power, like that. So even ax equal to e to the x power. Okay, then now what do you see? I'm gonna zoom in a little more so you can see a little better. So what do you see here? So I'm gonna turn off all other function and then start from first one. That's first graph, second graph, and third graph, and fourth graph. No matter what, this one passing through this point here, right? Point on the y-axis. So this point we can call 0 and 1, and then there is our y-intercept. Therefore, we can say y equal to bx line always pass through 0, 1 point. That is our y-intercept. Okay? Then now, using this one, we can determine domain and range as well. But this time we focus on doing domain first. So let's go back to this graph again. So what do you see here? So I'm going to zoom out more so you can see it's easier to determine domain value. As you see, all this function graph located on the left side and the right side here, right? And then even this one too, same thing, locate on the left side and also right side, and this graph too, even this graph as well, right? So therefore, domain is all real number basically. Okay, then what about the x-intercept? Based on this, we cannot find x-intercept because this graph never passed through x-axis. You know, the x-intercept is always located on x-axis, but this never passed through x-axis, so there's no x-intercept. But we can find maybe x-intercept for other transformation function though. Okay, that we will cover from the next video.